The top shelf in a cupboard contains 3 cans of pumpkin soup and 2 cans of chicken soup. The bottom shelf contains 4 cans of pumpkin soup and 1 can of chicken soup. Lucas is twice as likely to take a can from the bottom shelf as he is the top shelf. Suppose Lucas takes 1 can of soup without looking at the label. So the significance of without looking at the label is to make the thing random. It's like drawing names out of a hat. Determine the probability that it is chicken, that's part A, and part B was taken from the top shelf given that it is chicken. Now something like this lends itself really well to a tree diagram, because you've kind of got these successive events happening. Firstly, it's does he go top shelf, bottom shelf, and then once he's done that, it's does he take chicken or pumpkin or chicken. So I am going to draw a tree diagram. Now there's only 2 stalks on each one, and actually if you've drawn a few of these, you kind of get used to it. It's a lot easier to kind of start from this way. You don't run out of space. So if I just draw it just like that, and so you've got 2 things, as I was saying. You've got shelf and you've got type of soup. So shelf is our first thing, so it's which shelf, and the second thing is which soup. So you should put outcomes at the end of the stalk and probabilities here. So we go top and bottom, so I'm just going to call that T and B, and then I'm just going to call we're going to go pumpkin chicken. So pumpkin chicken, pumpkin chicken. So this now covers all the events. So this is Lucas goes top shelf and gets pumpkin. This is he goes to the top shelf and gets chicken. This is bottom shelf and he gets pumpkin. This is bottom shelf and he gets chicken. There's nothing else that can happen from this scenario, this fictional scenario of Lucas getting some soup. This covers all possible eventualities. Now we need to put some probabilities on it. So if we start with the shelf, it says he is twice as likely to get a can from the bottom shelf as he is the top shelf. So if you think twice as likely, yeah, you could kind of probably form some kind of equation for this, but if you just think about it logically, it's twice as likely. You can put one of them as 2/3 and the other one as 1/3. You know that they have to add up to 1 because it's certain that he's going to either select the top shelf or the bottom shelf. So which one's twice as likely? It's the bottom. So we'll call the bottom 2/3 and the top 1/3, and that covers it. Yes, they add up to 1. 1/3 plus 2/3 is 3/3, which is 1, and this probability is twice that probability, so that's fine. Right, now with these are called dependent events, because depending on which the probabilities of getting pumpkin or chicken is dependent on which shelf. There's different numbers on different shelves, so it does depend on which shelf you picked in the first place. So it says the top shelf has 3 cans of pumpkin soup even, and 2 cans of chicken. So that is 5 cans in total. 3 out of the 5 are pumpkin soup, so there must be a 3/5 probability of getting pumpkin, and there's 2 out of the 5 are chicken. That's on the top shelf. On the bottom shelf, we have 4 cans of pumpkin, 1 can of chicken. So that's 5 in total again. 4 of them are pumpkin and 1 is chicken. Okay, now it's probably a bit different. I'm just sort of drained from the IGCSE. I try and hammer it into them as much as possible, especially a little tree like this. Multiply at the end of a tree. So the probability of getting top shelf and pumpkin, you multiply these probabilities. It's the AND rule. So 1/3 times 3/5 is 3/15. Don't bother simplifying, it won't help. 1/3 times 2/5 is 2/15. 2/3 times 4/5 is 8/15. And 2/3 times 1/5 is 2/15. A little check. Now, you know that these should add up to 1 because it's all possible events that can happen. these should add up to 15 over 15. So 3, 4, 5, 13, 14, 15. So that's a great, it doesn't guarantee that I'm right, but it's certainly, if didn't add up to 15, it would guarantee that I was wrong. So now we can start to answer some questions. We just need to find the probability that we get chicken. So probability chicken. Okay, so that equals, now there's more than one way we can get chicken. So we could get chicken from the top shelf, or, keyword or, we could get chicken from the bottom shelf. Now, these are mutually exclusive events in that if top shelf and chicken happens, then bottom shelf and chicken can't happen, for example. So if one of these paths happens, it excludes all three of the others from happening. So once you have that, we can add. Or means add. So probability of chicken is probability top shelf chicken, so one way it can happen, plus bottom shelf chicken the other way. So it's 2 over 15 plus 2 over 15 equals 4 over 15. Okay, that was part A. Now we're on to the conditional stuff. So probability top shelf given that it is chicken. So probability top shelf given chicken. Now I keep saying the probability of one thing given another equals the probability of both over the probability of the given one. So probability of top shelf given that it is chicken is the probability top shelf and chicken over just the probability of the given one, which is chicken, which as often happens in these questions, we're using a result from a previous part. So it's very handy that we do actually already have the probability of chicken. So probability of top shelf and chicken, well, it's this number here, isn't it? So it's top shelf and chicken. So it's this number. This is top shelf and chicken. Okay, so this is going to be probability top shelf and chicken is 2 over 15 over probability chicken is 4 over 15. So that is, it's the same as 2 over 15 times 15 over 4. Well, the 15s cancel, 1, 1. And the 2 and the 4 can be a 1 and a 2. So the answer is 1/2.